In the early days of the Internet, a visionary named Tim Berners-Lee laid the groundwork for what would become the World Wide Web, a revolutionary platform that would connect people, information, and ideas like never before. As the web began to take shape, early websites were simple static pages, static HTML documents that displayed text and images but lacked interactivity or dynamic content. However, as the demand for more interactive and dynamic web experiences grew, developers faced a new challenge: how to make websites that could respond to user input, process data, and adapt in real time. With the introduction of databases, developers gained the ability to store, retrieve, and manipulate vast amounts of data, enabling a new era of functionality and interactivity on the web. Databases were seamlessly integrated into web applications, allowing users to register accounts, submit forms, make purchases, and interact with content in ways never before possible. However, with great power comes great responsibility, and the integration of databases into web applications introduced a new set of risks and vulnerabilities. One such vulnerability, known as SQL injection, emerged as a formidable threat, a consequence of inadequate input validation and improper handling of user-supplied data in SQL queries. With SQL injection, attackers could exploit these weaknesses to execute arbitrary SQL commands, bypass security measures, and gain unauthorized access to sensitive data stored in the database. Now, let's dive deeper into the world of SQL injection with a hands-on demonstration. We're going to step into the shoes of a hacker and explore how SQL injection works in practice. In this part of the video, we're gonna begin by exploring a lab provided by Portsugar Academy. This lab is entitled SQL Injection Vulnerability in Where Clothes, allowing retrieval of hidden data. So let's take a moment to read through the lab description and understand our objectives. This lab contains a SQL injection vulnerability in the product category filter. When the user selects a category, the application carries out a SQL query like the following: select all from products where category equals gifts and released equals 1. To solve the lab, perform a SQL injection attack that causes the application to display one or more unreleased products. Now that we have a clear understanding of our objective, let's dive into the lab environment and see what it looks like. So as we can see, this lab provides us with a simulated shopping website where users can browse products based on different categories. And as you can see, users can either browse products directly from the displayed list or choose a specific category to narrow down their search. This functionality is powered by SQL queries, as mentioned in the description. This SQL query does retrieve data from the... So based on the description of the lab and the application's behavior, it seems like when a user selects a category such as gifts, the application constructs a SQL query to retrieve data from the database. And this SQL query might look like this, select all from product where category equals gives and released equals 1. And this query is then sent to the backend server where it is executed against the database. And once the database returns the result to the backend server, the server processes the data and it sends it back to the user's browser for display. Now, to assess whether the application is vulnerable to SQL injection or not, we can begin by testing its response to certain input like a single quote to see if it triggers any error messages indicating potential SQL syntax issues, and if the application here returns an internal server error, in our case, it's a strong indication that the input is not properly sanitized and may be susceptible to SQL injection. And now, if you're lucky enough to have a SQL syntax error, we can start by crafting some payload to verify if it's vulnerable and to retrieve data. And here we can use the payload single quote or 1 equals 1 dash dash into the input field. And don't worry, we'll break it down. So the single quote here is used to terminate the string in the SQL query, effectively closing of the category parameter. And following that, we have the condition condition 1 equals 1, which always evaluates to true. And this means that regardless of the category selected, this condition will always be true, effectively bypassing any filtering based on the released status. And the dash finally is known as a comment delimiter in SQL and is used to comment out the rest of the query. This ensures that any remaining conditions in the original query are ignored and allowing us to retrieve data from the product table. Try now to trigger a SQL syntax error. And as you can see here, we were able to have an internal server error, which means that this parameter could be vulnerable to SQL injection. Let's try now our payload that we constructed earlier. As you can see, there are more products that are displayed now, and the status of the lab is turned to solved. So we actually succeeded in retrieving all data from the database.